Okay, in the previous video we found the equation of a line that was parallel to another line that was given to us in the problem and passed through a certain point. And now we're going to do the same thing, only find that for a perpendicular line. This is just a shorter way to write perpendicular. So a quick reminder, in the last video we wanted a line parallel to this equation here that passed through this point. What we did was, we know that parallel lines have the same slope, so we plugged in the same, so we found the slope of this line here, and we know that that's going to be the slope of our new line, so we just plugged that in for the slope of our new line. We used point slope form here and just plugged in those points right there. So kind of very similar to this, if we look at perpendicular lines here, say that we have this red line here and it's perpendicular to this green line. The relationship between these two slopes is going to be that each slope is the opposite reciprocal of the other slope. So what an opposite reciprocal is you take your first slope, so say that this red slope here is 1/2. You flip the fraction and then you add in a negative. So we took this 1/2, we flipped it, made it 2/1, and then added in a negative. Another way to do this is I like to think of it as flipping the fraction and then changing the sign. So if the slope is originally negative, you make it positive. If it's originally positive, you make it negative. So let's actually do a couple examples of finding the opposite reciprocal, just so that that doesn't give any issues, and then we'll go ahead and solve this problem using those concepts. So let's just start with something. Let's say we have 2/3. We want to find the opposite reciprocal of 2/3. So like I said earlier, our first step was to simply just flip that fraction. And then our next step was to change its sign. So it was positive, it's going to become -3/2. So this is the opposite reciprocal of this, and it could also be said this is the opposite reciprocal of this. What if we don't have a denominator on the fraction? So let's do, what is the opposite reciprocal of, say, 5? Well, I like to add in a little step here just to make it extra clear. I like to change that to a fraction. So 5 can be written as a fraction, right? As 5/1. So I'm going to change it to a fraction, and then it's just like this example up top. We're going to flip that fraction, so this is going to become 1/5. And last thing we're going to do is we're going to change the sign, so this becomes -1/5. If we do an example with a negative number, say that we have -1/2. What's the opposite reciprocal of -1/2? Well, we want to flip this fraction, so we have -2/1, and then we want to change the sign, so this is just going to be +2/1. And then of course you can always reduce these as you wish. So just a little bit on the opposite reciprocal, and then let's go ahead and solve this problem. So last time that we did this problem for parallel lines, we know that the slope of this line that we're given in the problem is 4, because this is slope-intercept form, y equals mx plus b. So the b value doesn't really matter, but we know that our slope is definitely going to be 4. And since we want the equation of a line that is perpendicular, the slope of our line is going to be the opposite reciprocal of 4. So what's the opposite reciprocal of 4? So let's take 4 and we'll write it as a fraction, just like that. We'll flip that fraction over. And then our last step is to change the sign, just like we did earlier. So the slope of our line that we want to write is going to be -1/4. So this is our new m. So we want to write a line with this slope, and we want it to pass through this point right here. So from here, it's pretty similar to all of the other problems that we've done. You can just pick any form of the line that you want, and then you can just plug in from there. So I'm just going to use a point slope form again. So we know that point slope form, we have y minus the y coordinate equals our slope. We know that our slope is negative 1/4, so I'm just going to plug that in right away, times x minus the x coordinate. So this y naught and x naught, if you remember from our earlier videos, is just any point that is on the line that we're trying to describe. So pretty good options for y naught and x naught. Whoops, this is a x naught, sorry. So y naught and x naught, a pretty good choice would be just to use this line that we're given right here. So we can just plug in a -1 here and a -1 here, and then if we want to simplify a little bit, we can. This is just going to be y plus 1 equals -1/4 is our slope, x plus 1. And there's the equation of a line that is perpendicular to this line here.